Hello, I'm happy to present you our paper entitled I Don't Want to Become a Number, Examining Different Stakeholder Perspectives on a Video-Based Monitoring System for a Senior Care with Inherent Privacy Protection or Privacy by Design. This work has been done in collaboration with my colleagues Anton from University of Applied Sciences and Arts, Northwestern Switzerland, Kooshan, Pau, and Paco from University of Alicante in Spain. Demographic change and the increasing share of older people within the global population challenge care and social systems in all parts of the world. As a response to these healthcare challenges, technological solutions such as active and assisted living technologies are developed and funded. Among them are division-based systems that provide ongoing monitoring and are able to analyze the visual data and extract valuable information from it. While video-based AEL technologies are mainly perceived as helpful and beneficial when it comes to assisting older individuals, privacy concerns remain as the major concern. With this in mind, our study aims at informing the design of a video-based monitoring, active and assisted living system that effectively addresses privacy concerns while catering to the distinct needs of the target user groups, which in our case are older adults and other stakeholders involved in the process of care provision. Our team at the University of Alicante is working on the development of video-based monitoring system with privacy filters. Hereby, we can see how one of these proposed filters, the avatar filter, looks in live. Apart from the avatar filter, we propose blurring, pixelating, and elimination filter as displayed on this slide. With the elimination filter, even though we do not see anything which guarantees maximal privacy, the system is still processing the data, therefore the alarms and notifications will be sent just in the case of other filters. Apart from the proposed 4 filters, we offer a context-aware fall application model under the privacy by context paradigm, in which the observed person is able to decide the type of visual protection required or perceived as necessary, depending on variables of the context, namely the relationship with the observer, the time of the day, the level of nudity, the activity being performed, the room in which it happens, as well as the level of emergency. Therefore, with this example, we demonstrate context-aware fall application and automatic change of the visualization to an original image once a fall is detected. Here we can see an overview of the whole system architecture. The video monitoring system includes a series of cameras in the primary user's home, as well as an automated context extraction module. This module extracts cues about the context that will be used combined with the primary user's preferences to determine the visualization or the type of filtered video that will be provided to the caregiver on their interface. Therefore, in this example, with this contextual information, the observer can only see the avatar replacement filter, as this is the preferred view for this scenario as set by the observed person. The system therefore provides an interface for the caregivers where notifications, access to the protected visualizations, as well as communication with the primary users are possible. With this system in mind, we set the following research questions for our study. First, what are the different stakeholder perceptions and experiences of the system in general, and specifically when it comes to privacy? And second, what are the design opportunities for the further development of the system? To answer these questions, we conducted an empirical evaluation of our designed and developed video-based monitoring system. These comprised of user testing sessions with follow-up interviews in a realistic environment in collaboration with an assistive technology center, IAS Bologna, in Italy. The proposed filters were live displayed on a large monitor, while participants were requested to engage with the filters through simple activities such as moving around the room, transitioning between standing and sitting, using the phone, etc. Additionally, study users were prompted to vocalize their cognitive process, to think out loud as they completed these tasks. Special emphasis was placed on the significance of verbalizing and sharing their experiences while experimenting with the various filters. We gathered insights from various stakeholders involved in the care process, obtaining their perspectives on the entire system, implemented privacy filters, and the fall detection application. A total of 29 individuals participated in user testing sessions. Our participants were from two primary user groups: older adults, 65 and plus of age, and other stakeholders. Other stakeholders were healthcare professionals and technologists of the Assistive Technology Center mentioned earlier. Older adult participants lived in private housing or sheltered housing and represented different socio-demographic backgrounds. We used pseudonyms when referring to the participants. As part of the socio-demographic questionnaire, older adults were asked if they had any previous experience with active and assisted living technologies and which information and communication technologies they currently owned. We also measured their attitudes towards technology in general, TechPH score on the table, and their level of care dependency, CDS score on the table. Other stakeholders represented secondary and facilitating stakeholder groups of a care provider segment and had a diverse length of work experience in the care sector. Among other characteristics, we measured their affinity for technologies with the Affinity for Technology Interaction Scale, or ATI, on the table, ensuring a diverse representation of technological backgrounds among the participants. We divided our empirical findings into two main themes: user experiences and design opportunities. We could observe that privacy concerns were alleviated with this system with privacy filters. The system was particularly appreciated for its ability to enhance safety for older adults, enabling them to maintain autonomy and reside in their preferred environments. Privacy apprehensions were stronger in other stakeholders than older adults themselves. When talking about design opportunities, we highlight the human-centric aspects raised by the older adult participants. Beyond safety-related features, they emphasize the importance of increasing the opportunities for interaction with the system and by allowing communication with an operator, for example. We wanted to show you several quotes from our participants' interviews as a primer. Elena, 73-year-old, reflected on the acceptance of such system. I would also have some difficulty thinking about having a camera in my house, but if I knew that by using this system I could continue living in my own home, maybe it would even be acceptable. Other stakeholder group was more skeptical towards the system. For example, Antonio, psychologist of the Assistive Technology Center, expressed their perceptions of obstacles of using such system. It still gives me the impression of being watched. It's still a camera. It's just surveillance there. While Fabio, an occupational therapist, commented on the privacy mechanism embodied into the system. But you also know what's behind it with avatars. I mean, if you put it at your parents' house, you know who are those two people, even though they're avatars, they're your parents. Or if you put it on your patients. So, in the end, you know what's behind it. Viola, an older adult participant, raised an important human-centric point when it comes to acceptance of such technology in their homes. Yes, it is acceptable under the condition, I repeat, that it is not cold or purely mathematical and inhuman. I don't want to become a number. Our study reveals the delicate balance between privacy and safety concerns in the adaptation of video-based systems for older adults in active and assisted living contexts. Our findings highlight the importance of aligning technology design with user preferences, emphasizing user involvement and empowerment as essential components for successful implementation. Our research builds upon privacy by context concept by providing design recommendations for the video monitoring system development. As we move forward, it is crucial to navigate this landscape carefully, recognizing the evolving technological norms and the innate social nature of individuals while prioritizing their autonomy, security, and well-being in an increasingly digital world. Our forthcoming research will prioritize greater user involvement in the design process of active and assisted living technologies and emphasize the importance of enhancing the aging literacy of involved designers and technologists. We thank European Union's Horizon 2020 Research and Innovation Programme under the Marie Curie grant for funding this work, together with the European Cooperation in Science and Technology Coast Action Good Brother. We would like to end with the following takeaway messages. We contribute with a novel video monitoring system with 4 privacy filters and 1 contextual application, tested with 29 participants, informing researchers, designers, and practitioners with contextualized insights for design opportunities in this space. The novelty of our work lies in privacy by context approach, situated against the backdrop of privacy threats in video-based active and assisted living technologies, emphasizing the central role of users and their context-specific needs and decisions in system development. Thank you very much.